All right, I'm gonna try to solve part 2 now. I didn't think I'm gonna do it because it took me a really long time to solve part 1, and that's only because I'm explaining how to do it as I go. If I just blasting out the code without having to explain what I was doing, I'd be done like that. So, who wants to just watch someone type? Is this an ASMR video where you just hear me clack, clack, clack on my keyboard? Probably not. So, or maybe it is. Maybe you're listening to the dulcet tones of my voice and it's lulling you to sleep. So I think at this point, either way, I was looking at part 2 and it doesn't sound that hard. And I know famous last words, right? So I think we should try to solve part 2 now. And then I can rest in peace until tomorrow and then come up with another harder problem. So in part 2, blah, blah, blah. I think the main thing is we got to double the size of the board or scale the board up. That is like a piece of cake. Okay, we already have our code to kind of parse it bit by bit or take our input. We'll just write a little transform, given this input, turn it into this other input. Piece of cake, right? That's going to be easy. I think the one tricky part about this, so this is how the transform is going to work, pretty cool, pretty easy. The new board will look like this. The tricky thing is, so moving a package left or right still kind of does the same thing, but now a package consists of 2 boxes that have to be moved together, so left or right, that doesn't really need to change at all. But the difference is, if you are moving one up or down, we can't just move a single thing at a time. We got to move the entire package. So I don't think that is going to be super hard to do. And I guess also that means recursively, since you're moving 2 things, then those can recursively move multiple things. I guess worst case scenario is you have a little V triangle of packages and you move them up, and then one package moves 2 moves 2 more. Well, I guess 2 can move 3 can move 5, a little pyramid of packages getting moved up, upside down pyramid. So that's gonna be a little bit tricky, but yeah. And then the GPS one, we have to look at the left side of the box, left side of the package. So I think overall, not going to be too hard for once. Yesterday, part 1, super easy. Part 2, super hard. Some of them, these kind of go back and forth. So I think this will be an easy part 2, but we'll see what happens. So I'm just going to make a new file for this. It's easier than trying to make all my code kind of conditional and have to handle both situations. So we'll call this day 15 part. I'm going to call it day 15 b.prolog. Okay, first things first, let us write our code to transform the board and make it twice as big. So I'm going to write a little function called x, little relation x that I'll just use to kind of test out my stuff. Input, parse input, package it, yeah, okay. And then I'm going to put this at the top of the file because all my formatting is broken at the bottom of the file because I'm using character literals, and I walked through that in the last video. I don't know why that's the case. It's this Emacs mode. I'm probably doing something wrong. Maybe this is not how I'm supposed to type a character literal, but I don't know. So let's do this. We'll get all of our input. We'll say actually input from path. Yeah, no, input will be example. Right? So let's just, and we'll print the board. What does it print? Board. Print board, is that what we call it? Print board? Print. No, print board. Right, man, I swear to print room is what I called it. Yeah, that's what it's called, okay. Let's do, okay, so this I think will be enough to get us started, so. Yeah, okay, so actually directions does not change, right? So we don't care about that. Okay. And wait a minute, we want X. Yeah, okay, cool. So now we gotta write our code to transform the board. Okay, so let's think about this. We read parse packages, right? We have something called parse input. And where the heck did I put that code? Who organized this code? Some kind of clown organized this code, right? Actually, I think we don't want to do it at this level. We want to, so here's like our little rules, right? So, oh my God, I keep forgetting to close this browser window. It's getting in everyone's way. So we can actually kind of write down what we know about the state of the world as rules, you know? Sometimes it's good to just write down what you know. We'll call it like scale, transform input. What do we call it? Transform input, maybe. If we see this, then it becomes that. Okay. Yeah. Bird I can't see. My bird's sitting on my head. Should we say if we want to transform one list? Yeah, I think this is fine. We're going to transform one character into a list of 2 characters, right? Okay. If it's a package which used to be represented by O, now it's going to be a package which is now represented by square brackets, but 2 of them, right? And then dot, which means like nothing, is now 2 dots, okay? And if you have the robot, which is the @ sign, now it's @ sign dot. Okay, so now we just gotta kind of like map cat that over all the input lines. So let's actually say read file, parse input, room input, parse input. Yeah, okay, so we gotta say expand input, transform input. How about expand room? That's what we'll call it. Expand room. We'll do this. Yeah, okay. So let's do this. Read file, path. So let's get our example file path, okay, and then we'll like read file. So we'll read file path size input. We don't care about directions. So we got a room input, and then now we just gotta like write this expand input, expand room thing. So let's change our X up to be like this, right? That way we can kind of test it as we go. Yeah, read file. Okay, room input size. We don't care about size either. No, do we care about size? Yeah, I guess we do. What do we say? We want to expand the input now? Is that what we're gonna call it? Expand room. And then I guess once you do that, then you gotta parse that input. Actually, we don't need to copy all this stuff, do we? We can just say input. Yeah, I'm just gonna grab this whole thing, and then we can print it after that. Don't care about directions, and we'll say input equals, no. What do we say? Oh, input equals example. Okay, so yeah, and we'll say, what do we want to write? We want to write expand room, right? Expand room. Let's just write a version that kind of does nothing for now. Make sure we're like on the right track. Yep, okay. So that's working. Now we actually have to make this do something. So we just need to replace every character with 2 characters. I think the way I want to do this is, well, we're going to write something recursive because, you know, Prolog, right? But we could kind of do, we'll make this like tail recursive. Okay, so we'll like have like a relation like this, room input. Oh yeah, okay, we'll have in 0, in, and then out, 0, out. We'll have like a 4-part relation. So we're going to keep taking things off of in, 0, and sticking them on out. And these will kind of serve as like the accumulator, I guess, and this will be the final answer. So this will be like the input, and this will be the output side of the equation. Do we want to do it like, yeah, I think that's fine. Okay, so we'll do like that, and we'll just keep flipping through it till we run out of stuff to do. So what's our recursive base case? You know, we start with, or once we run out of input, we're done, you know, so both sides of that we're done, right? And then out, just, that's our output, is whatever the accumulator is, and you know, that's it, we pass that out. So that's our recursive base case, okay? Now let's say we got like a character, and then we got like more input, and then we will, wait a minute, I don't know if we actually need 4 different things here. So, 0, let's try it with 3, and then like recursively we're gonna say like transform input for character is like right, and then we'll say out 1 is append out. Okay, so we're going to stick that on the end of out 0, and we're going to call that out 1, and then we're going to recursively expand the room with more input. Out 1, and then out will still be the final answer. So yeah, we only need 3 things here. Input, we're going to keep recursing over input till it's empty, and then we're going to kind of build up this like accumulator. So this will be like our partial value each time until we finally say this is our final output, you know? So, and then, yeah, out 0, out 1. Now, do we even need to have, what is the point of having 2 things then, huh? Out 1, out. Why can't I just have 1? Can I do expand room out 1? Yeah, append. Okay, let's think. Can I do that? Am I tripping? Out. Just unifies to itself. Right? Append out 0. Oh, this has no value yet. Can't append it. Okay, yeah. So I think if we want this to be like tail recursively optimized and whatnot, we got to do it that way. So to expand a room for room input, like our 2arity version will just be expand room input. Our accumulator initial value is like empty list, right? Right. Okay, so I think I should do it for expand room. Wow, that was pretty simple, right? Did it work? Let's see. Read file. Oops, we're going to do X anyway. Yeah, okay, so I think that looks like somewhat right, but yeah, so here's the problem. We got to expand the room before we calculate the size. Read file. Okay, this is easy enough, actually. We'll just double the size after we expand it, you know. 0, height 0. Size equals, no, we gotta do it 2 separate statements. With 0. Height is height 2, and size is width 0, width height. Okay. X. Yeah, that looks pretty good. Wait a minute, what the heck? What? Read file. Input. Directions. Okay. let's pause for a second. The large example would now look like this. Who said anything about height? Twice as wide. Oh, no one said anything about being twice as tall, did they? That is my problem. Okay. Yeah. No. There we go. Okay. So that's cool, except now all the packages are missing, right? Because we changed, what it is to be a package. But that's easy enough, right? So parse packages. Let's think about this. So I think we got like two options. We can have a package. We can only keep track of like the left element of the package, or the left bracket part of the package. Or we could keep track of both of them. Yeah. Right. I think we'll keep track of both of them for now, and we'll decide whether we regret that decision later or not. But then, then we're gonna have too many packages. There are code to like figure out the positions of all the packages, which I believe is supposed to only look at the left side of the package. What does it say? Blah, 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 blah. I don't want to read all this stuff. Oh, measured from the edge of the map to the closest edge of the box in question. Oh, dear Lord. Right. Okay. Well, that's not... Okay, this is just going to make our life a little bit annoying. I think what we should do is just keep track of the left, and then if the left is on the right half of the map, then it's closer to the right. Distance are measured from the edge of the map closest to the box in question. Right. So does that mean we got to measure from the bottom edge of the map too? Yeah, okay. So I think if we just keep track of the left half of the box, like that's what we'll store in our bit vector, then I think that should be fine. We'll just like look, we'll split the board. We'll say based on the height and the width of the board, what edge is closest. Then we'll figure that stuff out later. Okay. So let's just change this to that. And let's see, do we got our boards now? Yeah, we do, but they're not printing correctly. So we gotta say, instead of printing, why are we printing it out as 0 anyway, right? They were never 0, they were always O. So object, then we got a package, then we gotta write it like that. And then we got a next position, print position. Position has to go up by 2, so we can't just print positions one at a time now. Well, okay. I guess we could do it like this because we're kooks, okay? Yeah, we're crazy kooks. So what are we doing here? We're saying if there's a package to the left, then we're gonna print the right half of the package. Man, look at us! Look at us! Look what we did. We did something smart. Smart. Why didn't that work? Right. Okay. Yeah. Okay. No. What? Next position. Sorry. We did this all wrong. Left position. Okay, let's try this again. Yeah, okay, that looks pretty good. So I think we're printing our stuff now. So there's 2 parts left that we got to do. We got to update our moving logic, which is like not rocket science, I think, but a little bit trickier. And then we just got to update our coordinate calculation logic. So I think I want to like uncomment out that code that prints the room every time we move, so we could kind of make sure we're not doing crazy stuff. So solve. Oops. Let's try to solve example. Oh, that's wrong. Because it's not moving stuff correctly anymore, right? So how do you move a package now? So yeah, right. How do we just? I just want to move it like 2 times to see if it's like doing anything that makes sense or not. Maybe we should just kind of work on our little X function and say we got our room, and then move. What we had like a move relation that can move it some certain set of moves, right? So let's look at our examples and we'll kind of get like the first move working and do some stuff like that. Yeah, did we say this is what we had, right, so far? Yep, okay, no, that's not what we got. Where's the, oh, this is a different example. You know what, okay, we don't need their help. Let's move this like left like twice, and that'll put us, let's move it left like once, and that'll put us under this box, then we'll move that one up, and we'll see what happens. And if we get that working, I think we could be pretty happy. And we'll go from there. So let's work on moving a package left. We got our little move, okay. So we got this. Directions, packages, 0. And what do we say? And because we are encoding double quoted list of characters, we are treating that as actually, or sorry, double quoted literals like this are actually being read in as a list of characters. We can actually just write our directions. We say we want to do left and up, right? We can just write it like that. That's a list. I will show you guys. So it's like literally a list with 2 characters in it, right? So that's pretty sweet. We can just write our directions like that. Couldn't get any easier than that. So we want to move left and we want to move up, and then we want to see where the heck we are. Actually, let's just do just left and just see if we got that working, right? So yeah, so we print it. And then, oh my God, what in the world just happened, right? Wow. Huh, no, that's not what I expected. Okay, so the robot just disappeared. But why? Okay, our moving package stuff we didn't update, so something's definitely going on there. Oh, you know why? Okay, because there's no package here as far as the bit set is concerned. There's just a nothing here, and we move it here, but our printing code first looks for if there's a package to the left. So I guess we gotta actually update this to say, is there a package, right half of a package, when we're moving. Okay, so yeah. So our old code said if there's no package here, then we're done. But now it's no left half of a package where we're moving. But that is no longer true. Or right half, okay. So let's call this one. Okay, so we're gonna have to rework this whole relation, but I don't think it should be too hard. for once in our lives, Prolog is gonna like make our lives easier at solving this stuff than not. Okay, so how do we tell if a package is out of position? Oh, here. Package. Let's write a new relation, package at position. Okay. Package left position. Well, okay. Hold on a second. Yeah, a package is out of position if there is a package left. What? Okay, so either that position is the left, or there's a left immediately to the left of it, right? So, okay. So, package is at a position if let's break down that package left half is at position. Then we'll say yes, or we could say left position equals -1 at position. Let's write a little note to ourselves about what we're doing. Okay, so I think, right, yeah, okay. Okay, so maybe we don't need to like kind of wrap all this stuff up like that yet. That's not how I wanted that indented. Okay, so if there's no package at position, then we're done. No package at position. Packages. We are done as we were before. Okay, but then the next position. Now we gotta decide if we're working on the left or the right. So I think we'll change this relationship even more. We'll call it side. We could actually do it like this and make this two separate relations. I think left half. Yeah, okay. So now I should be able to, like, by using this relationship, be able to get which half of the package we're looking at. Okay, so no. Okay, I think maybe we need separate code for moving a left half versus a right half. Yeah, let's think about this. Okay. Okay. Right. Then we'll do a bunch of nonsense. Otherwise, I'll just say I'll put a placeholder in for now. Otherwise, we're moving the right half. And then, I don't know, I'll put more placeholder for now. Okay, so. Okay, so there's where our code's gonna live. This is gonna be the code for moving a package from the left half. Or move from the right half. So let's see. Now, if we move the left half, then we also got to move the right half. And right. And we both move them the same way. You know, they both move. If you're moving to the left, they both move to the left. You're moving up, they both move up. But then we just kind of got to recurse for both of them instead of just recursing once. I think that's easy enough. So actually, I don't even know if we need to have a or in this case. Okay, so we'll write this other relation. We'll do other half. Is this even the best way to write this? We could also just say there's two types of halves and get all the halves and get one that's not this. Yeah, I think this is fine. Let's not overthink it. Okay, so we'll do this. This is gonna blow you guys' mind if this works out the way I think it's gonna work. Okay, so other half. So now we should have the other half, okay, and then we just gotta get like the position for the other half. So let's try to solve for other half position now. So I think in this case we'll do like a conditional equals right half, then other half position. There's position plus 1. Otherwise, nope, that's not what I meant to do. I meant to do a cut, like a if-else type cut situation. Other. Okay, so now we should know what the other half is, the position of the other half. Right. And then now we got to calculate both next positions. Okay, so I'm going to call these next position A and next position B, I guess. And we got to say there's no wall at either position. Or we can't do anything if there's a wall in either position, right? So move half. That comment's like kind of useless now, right? So let's get rid of that comment. Okay, we know the other half position. We're checking no walls, okay, and then we gotta update all the bits. Let's write some notes. Check for walls. Update bits, and we're still just updating the left bit. So maybe we do want to kind of figure out which one is which, left side, right side. Update left side bit. Recursively move both sides. Yeah, and then what did we say earlier? Move left half into the ether. Recursively move both sides, and then put left half into its new position. So okay, so I think we'll change this up a little bit. So if the other half is the right half, then left position equals package position. Otherwise, left position and the right position. Yeah, because you should be able to move it from either side, right? So we'll get the other half. We'll figure out. We'll get the package half that we're dealing with. Okay. And then we will figure out what the other half is, and then I guess there's no point to figuring out the other half because, you know, yeah, this is not useful. Okay, so we'll get if there's no package deposition, we're done. Otherwise, this goal succeeded, which means these are all unified or whatnot. This package half will have a real value. We said we don't need other half. If package half is the left half, then left position is, you know, whatever position you passed in. Right is the position plus 1. Otherwise, left is the position to the left, and, you know, right is the position we're dealing with. Okay, so then we'll say left position will be, we'll call this next left position. And then this will be right position. Okay, we gotta check for walls. Next left position, next right position. Okay, I think that looks good. Now then we'll move the left half into the ether. So this, because we want to move the left position regardless of what position you pass in. If you're moving from the right, we actually got to move the bit because we're only storing the bit that has the left, right? And then we got to move both sides recursively now. So we got to move package. Let's move. Do we move the right side first or the left side first? Oh no, this is good. This is. If you're moving left, you gotta. So we're kind of moving like in a depth first manner. So if you move the left first, then it kind of makes way to move the right, and that's cool. Otherwise, if we move the right first, it's going to land on top of the existing. At least it wouldn't land on top of the existing left because we moved that into the ether, right? So let's see. So one of two things is going to happen. We're going to do this and it's going to explode, or do this and it's going to work fine. What if you move something to the right? You move the left first. We move that to the ether. Then we move the right side, and that moves the left back. I think. I'm trying to think if we need to do anything special depending on what side we're moving, or if we can just recursively do it the same way regardless of like what direction. So let's just try. Next left position. Yeah. See how well this works. I'm not convinced. It seems like too easy, right? Yeah, okay. Maybe that's all we need to do. Left half. What's wrong here? Why are you being unhappy? Oh. It's not. Okay. Try that again. No. Something happens. Okay. So I think we didn't move. Let's add some print lines. This is what print lines are for. Yeah. So package half, package position. Let's print left half. No, left position. Next left position. Right position. Next. Okay, try that again. Next left position should not be. Oh. Should not be a logic variable without a concrete value, right? Is what I was going to say, but that's because I didn't give it one yet, so. Okay. Right. So we're trying to move the one at 87, which I think is like that one, right? No, wait a minute. So we're moving left, right? So shouldn't we run into the right half first? Uh-oh. So yeah, okay. That can't be right. We move the robot, and then if there is, then we try to move the packages at the robot position. So let's. Robot position's 87. Okay, so we're trying to move. All right, it is now. We're moving to 87. I guess it must be 88. We're moving to 87. So there's a right half right there, and so you would think this should be saying, well, yeah, okay. There's a right half because there's a package at 86, right? But let's just make sure I got this robot position 0. Yeah, okay, so we're moving from 88 to 87. Okay, so there should be a right half of a package at 87, but for some reason it's not picking that up. It's saying left half is at 87. So that can't be right. So let's just turn off like the right half printing for right now, just so we could kind of like visualize what the heck's going on. Yeah. So we're here. Oh. You know what? I think I'm tripping myself up by looking at the outputs on the wrong side of things. Okay, so this is the board, and then we're doing. Where are these print lines in relation to everything? Next position. Move package. So we're moving the package. Yeah. Are we printing before or after the move? Yeah, so we're printing before the move. So this is before what it looks like. And this is all the like calculations that are involved in making the move. And then, you know, that's like the result. So let's look at it without printing the right. So this is before. So package half, left half. But there's no package at the left half, right? There's no package right at 87 where we're about to move to, right? There, that doesn't make sense. So package at position doesn't seem right. Package half, left half. Yeah. So this goal succeeds. The package half should be right half, right? Okay, I'm going to turn that printing code back on because I think we know what the problem is. We want to move from 88 to 87, and then at 87, we're saying there's a left half. Maybe because is this just assigning this because it doesn't have a value yet? Oh dear Lord, what did I do? Yeah, okay. So, you know, you would have thought if this goal failed, then we do this, but if we get to this other branch, then, you know, then it didn't fail, it succeeded, and this should have been given a value. But that's not what it's doing. It's doing something dumb. So, it's not propagating this, I guess. You know what? I don't really 100% understand why that is, to be honest, but I'm not going to waste my time trying to figure it out right now. So we'll do this instead. We'll just run that again, and I guess I don't want to like restructure all this code. If I was writing like Clojure code or Lisp or something, and it's so easy to just like change the if and the else because you just cut like swapping forms around that do it, but like swapping this whole thing around is gonna like make me cry. So I'm not gonna do that for right now. Okay. X. Yeah, cool. Looked like we moved that package, didn't we? Okay, that looks good to me. Let's try to move it twice and see what happens. Where the heck is my X code? Yeah, okay. What happens when we move it 3 times, huh? Nice. Can we move it 4 times? Nice. What about 5 times? It should no op, right? Yeah, cool. Okay. So now at this point, let's go back to like moving it twice. And let's see if we can move something up. Does that work? Yeah, it looks like we're moving things up correctly, right? What about 2 up? Should no op, right? Yeah, okay. So let's try moving stuff to the right, and we'll try moving stuff down, and then I think we'll be pretty happy with it, right? Man, this is like a lot of like work typing this over and over. So I'm just gonna do like moves, directions, and make that the input to this relation. And so we'll say X. And just to make this like a little bit more user friendly, I'm gonna have it cut here so Prolog doesn't have to try to solve for anything else, because like I don't know if you guys noticed, but before I did that, I typed something in and then it would ask me, do I want to look for more? And I could press semicolon to look for more solutions, or I could press period to have it stop looking for any more solutions. And well, I know there's no more, so I'm just going to tell it to cut, stop looking for things, and then it's going to save me some typing. Okay, so we're going to say like, right, yeah, cool. What happens? Oh, wait a minute. Let's go up 1 and then move right. So we're here. Oops. Yeah, and then we're gonna move right like twice. Oh, damn it. Didn't I literally just say do a cut so it wouldn't ask me for anything else? Forget it. We'll do it like this. Okay, cool. Done. See, now it's right back to the prompt, you know? Let's move right 3 times. We should run into this. And then if I move right a 4th time, it should move that whole box. Yeah. 5th time right here. And 6th time should do nothing. No op. Yeah, cool. Okay, I'm pretty happy with that. Let's look at moving down. So I'm gonna move right twice and move down. Down. Did we test whether we could move a box 2 boxes at a time? We didn't test that, right? So let's move this down and then we'll go test that next. Yeah, that looks good. Okay. Now we'll move to the left 1, 2, 3 times. No, that's not what I want at all. Okay. Yep, let's move that one left. Then we'll move down. And then, you know what we should really do here is like make this like interactive in the REPL where it like asks you for 1 character at a time. I don't have time for that, honestly. We'll move to the left once. I think this is fine for now. Let's not waste time doing nonsense. Can that move both our boxes? Oh my god, it can. And what happens if I try to move up again? It's not going to move one of them, but yeah. Oh my god. Wow, it works. Okay. There, that's pretty neat, right? You gotta admit, pretty neat. Don't need to print all this stuff anymore. Yeah. Let's yeah, we don't really need to print the board every time either. So I think at this point, we can look at like blah blah blah. The robot's finished all its moves. It should look like this. Okay, so let's try to look and see if we actually like got if we're like close to what it's supposed to be. So I think it's called like solve. What do we call it? Solve example out. Okay, I mean our number is wrong, but I expected that because I haven't updated the code to do the new position calculation. But this looks pretty good to me. So yeah, I think we did all of our moves right. But wait a minute. The sum of the box's GPS coordinate is 9021. What? I thought they said the rules for the coordinates changed, right? But I already got the right answer. That can't be right. You know, I think this is probably badly explained or something. For the larger boxes, distances are measured from the edge of the map closest edge of the box in question. So I guess we're still measuring from the top and the left then. The closest edge of the box. And okay, so you know what? That wasn't super clear. It said closest edge of the box in question. So we're still measuring from the top left. You know, I would have thought the right edge is closer to like the edge of the map in question. That wasn't super clear to me, but maybe I just was not reading clearly. Maybe this was on me. So cool, but that makes our lives easier. We're already done. No need to do the GPS updates. So I guess the only thing at this point is to see if we solve the second half correctly or not. So let's try this with the actual input. Oh my God, I should not have printed that, right? Let's just abort. We don't need to print every time. It is nice to look at it, but it's going to be slow. Where did I? Oh, print room. Yeah, we don't need to do that every move. I think that's the only place we're calling it. And we don't need this X here either. And I'm going to move this down now. I know. People are like waiting with bated breath, but I'm like refactoring the code before I actually run it. Okay, cool. Let's try it again. Bam. Now let's try it. See, is that the right answer? Yeah, cool. I did it, you guys. Nice. And we actually did it in like a timely manner today too, you know. So if I wasn't explaining everything I was doing, I think, you know, it would have taken, I don't know, like 20 minutes to do. But I spent half an hour yapping and trying to tell you what, guys, what's going on. So some of this makes sense. Cool. So that one was really straightforward and pretty easy, I think. Prolog made it really easy because I can just have it recursively try to move a bunch of stuff. And if it fails, then you know, we could just have it backtrack and say it's not doable, you know. So that did make my life a little bit nicer today. I think most of the other stuff is probably going to look pretty similar, and no matter what language you do it in. I think using a bit set was a cool call. I did waste a lot of time having to write basic bit set manipulation functions, you know. And if I was using like a Java util dot bit set or something, I'll pull that up if I could figure out where the heck it lives. You know, this is what I would have used. So I think I've said this most of the time I write closure code. That's like my day to day. I would have used bit set, I think, you know, because really you can just represent all the walls are just bits. Is there a wall here or is there not? Is there a package here or is there not? So bit set, you know, I think is a pretty good fit for this. And it has like a lot of nice things like get the bit at this index, set the bit at this index, all this other stuff. And, you know, I didn't have any of that in Prolog. I had some stuff like that, but, you know, like set bit, I had to go write that myself, you know. But I guess that wasn't too bad. And I already have that. Now I have that for next time. And, you know, are we going to be working on more grids for like the rest of the problems? I'll bet you $100 we will be. So now I got that for next time. So this is cool. Fun problem. Not too hard. Thanks everyone for joining me, and I'll see you around next time.